Saxon's Trig, lesson 38 on page 269 is about the fundamental counting principle and permutations, designated roots, and overall average rate. So we begin with the fundamental counting principle and permutations. Let's start with the permutations part of that, not the fundamental counting principle. So a permutation is trying to ask you in how many ways can you arrange a set of whatever you're being provided. So if I say I have the letters A, B, and C, in what orders can I write A, B, and C? Well, A, B, C being one of them. It could be A, C, B. It could be, that's the only way to start with A. It can be B, A, C. It can then be B, C, A. That's starting with the A, starting with the B, starting with the C's. C, A, B, C, B, A. So there are 6 different ways that I can rearrange those letters into unique patterns. So that is a permutation. Then when we flip over to page 270, they give us the fundamental counting principle. I'll read it and then I'll try to put it in a little more understandable wording. If one choice can be made in A ways, and after the first choice is made, another choice can be made in B ways, then the number of possible choices in order is A times B different ways. So the fundamental counting principle basically says if you have 3 letters and you're going to be arranging them in order, so I'm going to fill 3 blanks in. I multiply, so after I fill in how many possible choices I have, then I multiply each of these answers together. So the fundamental counting principle is basically telling you to multiply your number of choices. So if I had 3 letters here, how many letters do I have to choose for the first blank? 3. But after I've chosen either the A, the B, or the C, how many choices do I have for the next choice? Only 2 choices, the B or the C in this case. And then I only have 1 choice left, and so 3 times 2 times 1 is 6 total possible ways. So I can either try to listing things out, which takes too much time, or I can use the shortcut permutation in combination with fundamental counting principle of multiplying them together. I quickly get my 6. So now let's do example 1. How many different ways can the numbers 3, 5, 7, and 8 be arranged in order? No repetition is permitted. So that repetition piece becomes very important in my choices here. So I was given 4 numbers to choose from. So I have 4 blanks that I'm filling in. Into this first blank, how many choices did I have? The 3, the 5, the 7, or the 8. So I had 4 number choices, and it says I cannot repeat. So whatever number I used, I no longer have it. So that only leaves me 3 choices for the next one, then 2 choices for that next one, and only 1 choice for the last, and I know that I'm supposed to multiply all of those together. So 4 times 3 is 12, times 2 is 24, times 1 doesn't matter. So there would be 24 total choices. They wrote the word ways with it. Whether you do or don't have that is not as critical with these, even though it does act as a word problem. Example 2, how many 4-letter signs, so I know I have 4 blanks, can be made from the letters in the word equal if repetition is permitted? All right, so how many letters would I have to choose for the first blank? 1, 2, 3, 4, 5. Okay, but I'm not throwing out that letter because it said I'm allowed to repeat. So all the letters are still here in play, still 5. Not undoing it, they're still all there, so 5, and again, 5 more. Multiply all of those together. 5 times 5 is 25. 5 times 5 is another 25. 25 times 25 is 625. Example 3. A multiple choice test has 8 questions. 1, 2, 3, 4, 5, 6, 7, 8 blanks then. There are 4 possible choices for each question. How many different sets of answers are possible? Is there a reason why I cannot repeat answer choices? Nope. So it said I had 4 choices. and I'm allowed to repeat them. So it's basically a 4 filled in all of those times. That's the same shortcut on my calculator to help me as 4 to the 8th power. So rather than writing out all the 4s and trying to do all of that, I'm just going to shortcut and use the calculator 4 to the 8th. Could I have done that here? Sure. This would have been 5 to the 4th. What does this look like? 4 times 3 times 2 times 1. Factorial. Oh, I could have shortcutted to 4 factorial here, button on the calculator. Same thing here, 3 factorial. So you can begin using shortcuts as you are spotting them. That's perfectly acceptable. So this 4 to the 8th is a huge number, 65,536 possible choice combinations on an 8-question multiple choice test. Whew, okay. Example 4. How many 3-letter signs, 3 blanks, can be made from the letters in the word numeral? So numeral. No repetition is permitted. Okay, now I am not allowed to repeat. So how many choices for this very first blank? 1, 2, 3, 4, 5, 6, 7 choices. So whichever one it was, I no longer have it. Let's pretend it was the end. So how many choices? 1, 2, 3, 4, 5, 6. Then again, I can't use that one, so I have only 5 choices left. And we're going to multiply 7 times 6 times 5. Now, you couldn't use the factorial here unless you chose to do something like 7 factorial divided by what you're no longer using, 4 and down. You could do that as the shortcut. Or this case, it might be faster to just do 7 times 6 times 5. But however you choose to do it, you should be getting 210 for its answer. All right, that's all of the examples for section A. Now, section B, page 272, designated roots. All right, the key here is the fact that the word roots means answers to a problem. So they're telling me they're going to give me the answers, and I'm supposed to work it backwards and find the original equation. Example 5. Write the quadratic equation. Okay, what's that tell me? Quadratic equation is I've got something like x squared with an x with a number that doesn't have an x, and whose lead coefficient is 1. All right, now they have to clarify this. And all it means is that you must have a 1, no other number in front of your x squared. The lead coefficient, meaning the first one, must be a 1. If they don't clarify this, then your problem could have multiple other numbers in front that can completely alter the problem. But they will always clarify, and it doesn't matter in your solution. But if you should get a number that's not 1 at the end, you know you've made a mathematical mistake somewhere along the line. So write a quadratic equation with a lead coefficient of 1 whose roots are, so the answers are -3/5 and 1/2. So if you picture a quadratic equation that always equals 0, and these were the answers that got spit out. So like at the end it said x equals these two things. Where did those come from when you had factored? They came from 2 parentheses. So we had, and I stated it in an earlier lesson, but it's worth repeating many, many times throughout Trig. When I am pulling a number out of a parenthesis, I change its sign. When I'm putting it back into a parenthesis, I change its sign. Oh, I forgot to write my other x here. So this is going to fill in as +3/5, and this will fill in as -1/2, and the whole thing equals 0. So you see, if you were solving at this point, x would equal -3/5, x would equal 1/2. But we're working it backwards. So these were the answers now filled in, and then we're going to distribute FOIL, however you wish to think it, till we get it back to an answer that looks like this. So x times x, x squared, x times -1/2, 3/5 times x, 3/5 times -1/2, negative, 3 times 1, 3, 5 times 1, 5 times 2, 10. Now, these are my like terms, so we need x squared, and I need a common denominator to put those together, which will be 10. So if this one's 10, this becomes 5. If this is 10, that multiplied by 2, so this becomes 6. -5 plus 6 is +1/10 x, minus 3/10, the no like term to combine it, or to go with it, equals the 0. It's a quadratic equation, so it always equals 0. And although this is the correct answer, oh, they didn't do it in this one. That's funny. Typically, they say we don't want to see fractional answers, and so they'll end up multiplying everything by 10 sometimes, but that ends up putting a 10 in front of this, which negates this piece, so just box it. It should have the 1 in the final answer. Let's do example 6. Write the quadratic equation with a lead coefficient of 1, that language you'll always see, whose roots are. So we know we're going to have a parenthesis and a parenthesis, and it's going to equal 0, and it'll have x and x. And if the answer was 1 plus root 2, we're going to fill in minus 1 minus root 2, changing the sign, putting it in. And the other one, 1 minus root 2, so negative 1 plus root 2, changing the sign on both as we plug it in. Now, this is definitely a distribute, not a FOIL, because there are 3 parts. So x times x squared, x times negative 1, x times the root 2, negative 1 times x, negative 1 times negative 1, negative 1 times root 2. Now we move to this one, negative root 2 times x, negative root 2 times negative 1 turns it into positive root 2, negative root 2, positive root 2, so the negative wins out, and then root 2 times root 2 kills the root and keeps the 2, and the whole thing is still equal to 0. Now, x squared, nothing changes it. I have a negative 1x and a negative implied 1x here, so that's negative 2x. Then I have this positive root 2 with an x and a negative root 2 with an x. Technically, this x should have been written here in front to avoid the confusion that it might be inside the root, but it's not. So these are the same with opposite signs. They're going to cancel off. Positive 1 and negative 2 are like terms, so that will be a negative 1. And then this negative root 2, positive root 2, same thing, opposite signs, cancels off, equals 0 then is still there. And there's the formula. So, yep, x squared minus 2x minus 1 equals 0. Now we shift gears to the overall average rate. These are word problems, and you know how we find a rate is a fraction, and an average, you know, is where you add up everything and divide by however many numbers you have. So we're going to combine that into this word problem. Frank and Judy drove for 100 miles at a certain rate. So I immediately recognize rate times time equals distance. Okay, so they drove for 100 miles distance at 50 miles per hour rate. Don't know the time, but I could solve for the time, and the time here would be 100 divided by 50, that's 2. Next sentence. They can drive 180 miles at 60 miles per hour. Again, I don't know the time, but I can solve for the time. 180 divided by 60 is 3. Next sentence. What is Frank and Judy's overall average rate for the whole trip? So overall average rate, immediately, it's a reference to what I've just been doing. It's because it wants the average, wait a minute, did it say? Rate over the whole trip. Okay, so that's going to be total distance divided by the total time will give me the rate. From this formula, if I'm solving for rate, it's distance divided by time. The difference with overall average is that it needs to be the total distance for the trip and the total time for the trip. So my total distance is 100 plus 180, so that's going to be 280 for the numerator. The time, which is why I needed to solve for these, added together is going to be 5. And just was double checking. Yes, okay. So then 5 goes in here, 5 times 20, so 30, so 58. And we were finding rate, so we know that that is miles per hour. All right, example 8. I don't think I had space to do it there, so let's change the page. There it is. Frank and Judy drove for 100 miles at 50 miles per hour. 100 miles, 50 miles per hour. Again, I don't know the time. Time is 2. Then they drove 180 miles. This is just like the last problem. At 60, again, I don't know the time, so I solve. Time is 3. How fast must they drive for the last 120 miles? Ooh, so I have another 120 for the distance, and it wants to know how fast I have to drive here to have an overall average rate of 60 the entire trip. Okay, so I need to use the total here as I work. So the total distance is 100 plus 180 plus 120. So that should be 300. 400, okay, is my total distance divided by my total time. I do not know how long it took me here, correct? Just want to make sure I didn't skip anything. All right, correct. So that would be 2 plus 3 is 5, plus the unknown time over here, which I don't know. So that's the third's time. And it said, I feel like I've missed a piece somewhere. Hang on a second. The key that I was looking for was in my total distance divided by total time gives me my overall average rate, and they told me that that was 60. So I knew I needed another number. It equals 60. And ultimately, after I find the time here, which I will fill in here, we will get the rate, which is what they're ultimately looking for. So this 5 plus t needs to multiply over here to the other side. So we're going to have 400 equals 60 times 5 plus 60 times t. Move this number over to join. It subtracts 100 equals 60t. Divide by 60, so the t is 5/3. So this time filling in over here is 5/3. I'm just going to rewrite it. 120 equals, we're looking for the ultimate rate here, and it's multiplying with 5/3. And since we want to remove this fraction, we flip, because it's going to divide, we flip and multiply. So it implies 120 over 1 times 3/5 equals the r. 5 can divide in here 1 time, 5 can divide in here 24. I'm looking for their final answer to make sure that when I multiply this, I'm going to have it. I think that's correct. So 3 times 4 is 12, 6, 72. Yes, okay. So the rate will be 72 miles per hour. So a little more complicated, but as long as you take each individual piece, you set this up so you know what you're ultimately looking for, then you have to use the overall average, which was total distance divided by total time, and they provided you with what that actually equaled.